Okay, so we finally started talking about circular motion. So refer to section 4-7 in your book. We'll do uniform circular motion. And what that means is that the the speed is constant. So if the speed is constant, and if you look through the PowerPoint lectures and read that section, you'll see the centripetal acceleration, some people call it radial acceleration, turns out to be v squared divided by r. So if you're going in a circle, r is the radius and v is the speed. And this acceleration is always directed towards the center. So if you're going in a circle at a constant speed, the speed is going to be the distance around the circle, 2 pi r, divided by the time it takes to go around once, and this is a special time called the period, so we use capital T for period. There's one other way of looking at this. There's something called the frequency. I could rephrase this as 2 pi r times the frequency. So the period is 1 over the frequency. So, in other words, the frequency is 1 over the period. And it's measured in 1 over seconds. So 1 over seconds is something called a hertz. The lab that you do on Thursday, you'll measure the frequency and be able to calculate the force that's towards the center. Looking ahead a little bit, if the acceleration is directed towards the center, this is the net acceleration. If there's an acceleration towards the center, there's got to be a net force towards the center. So imagine you're spinning something in a circle. Maybe with me I would be spinning my daughter in a circle, and I'm holding her with my arms, and if I happen to let her go, she would go flying off, following a path that she would have taken. So I've got to have a force towards me, so a force on her towards me, towards the center to keep her going in a circle. Okay, so these are the two equations really from this chapter dealing with circular motion, and these are the ones we can use to solve a whole bunch of problems. The next section we'll do after this is 6-5 and look at the actual forces towards the center. Okay, so in just a second I'll do problem 58, and then I'll go on and do number 66.